today we are going to continue our algebra review. Today we are going to learn how to solve systems of equations using the elimination method. So when you're solving using the elimination method, you're going to get both equations into standard form. What I mean by standard form is AX plus BY equals C. So you're going to get both equations in this form, so that way when you go to eliminate one of the variables, you'll have the x's lined up, the y's lined up, and then the constants. Now, when we're doing the elimination method, we need to make sure that one of the variables, either the x's or the y's, have the same number but opposite signs. So that way when you combine the two equations, that variable will cancel out. Then after you solve for that variable, then you'll plug it back in and solve for the remaining variable. Remember, if both variables cancel out and you're left with a false statement, then it's going to be no solution. If both variables cancel out and you're left with a true statement, then the answer is all real numbers or infinitely many solutions. So let's go ahead and try it. So here is our first example. Notice they're both in standard form. It has the x plus the y equals the constant. Now, in order to use the elimination method, I need to decide which variable I want to cancel out. And again, it's totally up to you. I'm going to try to eliminate the x. So what I'm going to do is I'm going to multiply my second equation by -2, and then that will, when I combine the two equations, cause the variable x to cancel out. So I'm going to distribute a -2 to my second equation. And remember, when you're distributing this -2, it needs to go to both variables and the constant. So now this will give me -2x plus 2y equals -18. Now I'm going to take my first equation, I'm going to write it underneath. So 2x plus 3y equals 13. And now I'm going to combine the two equations or add them together. Notice my x variable cancels out, and now I'm left with adding 2y plus 3y is 5y. -18 plus +13 is going to give me -5. Divide both sides by 5, and y is equal to -1. Now, just like before with the substitution method, I need to find the x of my order pair. So now I'm going to take this y value and I'm going to go back to the beginning and plug it into one of the equations. You can choose. It doesn't matter which one you plug it into. So looks like maybe the second equation might be easier, but again, it's totally up to you. So if I take my second equation, and now I'm going to replace y with what I just found, which is -1. I'm going to rewrite everything else except for the letter y. In place of that y, I'm going to put -1. And now I'm going to add or flip this, and it becomes x plus 1. And then now subtract 1, and x equals 8. So now when I go to put it in my order pair, I write the x first and then the y. Remember, once you get your answers, you can check them. So for example, if I take my two original equations and I take the order pair that I just found and I plug it into both. If it doesn't work for both, you did something wrong and you need to start all over again. So remember, this is x, this is y. So if I put 2 times 8 plus 3 times -1, If after I multiply and add, if it doesn't give me 13, then I've done something wrong. But it does. 16 minus 3 is 13. It works for the first equation. Now let me test the other one. 8 minus minus, which turns into 8 plus 1, and 8 plus 1 is 9. This one checks as well. So the answer that I got, the order pair 8, -1, is the correct solution. If I were to have graphed these two lines, this is the point of intersection. Is when you're solving these, one little mistake, either with a sign or a computation error, if you make one little mistake, then your whole answer is wrong. So I highly recommend you do this check to make sure the answer you got does work. Let's try another example. All right, so for the next one, again, solve using elimination. This one's nice and pretty. It's already set up for us. I don't need to multiply any of my equations because if I just add these two together, automatically my x's are going to cancel. So already it's set up for the x's to cancel out. And now I'm just going to add 1y plus 1y is 2y. And then 10 plus 20 is 30. Divide both sides by 2. And y is equal to 15. Now I need to take that value of y, go back to the beginning. And again, you can choose. I think I'm going to choose the second one again. So I'm going to take y plus x equals 20. I'm taking out y, and I'm going to replace it what I just found y to equal. So 15, rewrite the rest of the problem, and now subtract. And x is equal to 5. So the solution, again, is in order pair. You write x first, which was 5, and then the y, which is 15. Sometimes when you're using the elimination method, the equation might be already set up for you, and then all you got to do is combine the two. Just add the two equations, and automatically one of the variables will cancel out. And again, you can do the check on this one, but 5, 15 is a good answer here. All right, so for the next one, notice this one's going to be a little bit more challenging. So nothing here is going to eliminate automatic. It's already set up in standard form. However, in order to get either the x's or the y's to cancel on this one, I'm going to need to multiply both of my equations. So I'm going to go ahead and I am going to eliminate y first. So I'm going to go ahead and change the number that's in front of y to be 10 and -10. So in order to achieve this, I'm going to eliminate x. That'll be a smaller number. So what I'm going to do is I'm going to take my first equation, and again, you could have also made them 10s. It doesn't matter. You can choose. So I'm going to go ahead and multiply my first equation by -2, and then my second equation by +3. This will make the first equation have a -6x, and the second equation a +6x, and then the x's will cancel. So let me go ahead and set these up. Let me go ahead and write this one down. This is the first one. And I'm going to distribute -2 to all three pieces. So -6x minus 4y equals -8. Now I'm going to take my second equation and I'm going to distribute the +3. So I'm distributing +3. So 6x minus 15y equals -87. So now I'm going to take the two equations, the -6x minus 4y equals -8. I'm going to write them on top of each other, and then I'm going to add the two equations together. And again, you could have eliminated y by multiplying and making them a 10 and a negative 10. It's totally up to you. So now when I go to combine my like terms here, notice the 6x's are gone. And then now I'm going to add negative 4y plus negative 15y and get negative 19y. And then negative 8 plus negative 87, negative 95. Divide both sides by negative 19. And we get y is equal to positive 5. I'm now going to take my newly found value of y, and I got to go back to the beginning. And again, you can choose which one to plug it into. I'm going to do the first one. I've been picking the second equation, but it looks like the first equation might be a little bit easier. And again, it's totally up to you. So again, I'm going to take out y and replace it with the 5. So 3x plus 2 times 5 equals 4. Multiply, subtract. 3x equals negative 6. Divide by 3. And x equals negative 2. So the solution to this system is the ordered pair negative 2, positive 5. All right, so for this one, notice again, it's set up nice and pretty for me. Notice all I got to do is add these two together, and my y's are going to cancel. So I'm just going to add the two equations. I don't need to multiply anything to make them the same. So once I go ahead and add these two together, the y's are going to cancel. And then now I'm left with 7x is equal to 42. Divide by 7, and x is equal to 6. Now I need to find y. So now I take my newly found value of x and go back to the beginning. And you can totally choose whichever one you want. So let me take the first one. So we get x minus 5y equals 21. I'm going to take out x, and put in a 6. So I put a 6 here, and then minus 5y equals 21. Subtract the 6. Negative 5y equals 15. Divide by negative 5, and y equals negative 3. So my solution to this system is the ordered pair 6, negative 3. So let me add one where it's going to either be all real numbers or no solution. Let me add an example here. So when both variables cancel out when you add the two equations together, if you're left with a false statement and 0 will never equal 10, then it's no solution. Now, sometimes you're going to have to multiply it to get it to this point. However, I just wanted to show you what happens after you try to add them. Let me try another one. Let's say we have 4x minus 5y equals 20. And then negative 4x plus 5, oh, that should be a y here. 5y equals negative 20. Notice cancels, cancels, cancels. 0 equals 0. This is all real numbers. Or you can also describe it as infinitely many. So on the test, be able to recognize these. So when you're left with a true statement, then it's all real numbers.